Hi everyone, this is an example of how to write a net ionic equation. I'm going to follow three steps. I'm going to first write the non-ionic equation, traditional balanced equation with states. Then I'm going to dissociate anything that's aqueous. I'll examine my work to cancel off any substance that's identical on opposite sides of the arrow, and I'm going to rewrite what's left behind. Here's the reaction. Aqueous strontium nitrate reacts with aqueous sodium carbonate to produce aqueous sodium nitrate and strontium carbonate precipitate. My first step is to turn this into a regular balanced equation, a non-ionic equation, and I must include the states. Aqueous strontium nitrate reacts with aqueous sodium carbonate to produce aqueous sodium nitrate and a strontium carbonate precipitate. Reminder, precipitate means it's a solid. I have the chemicals and their states. Now I must balance the equation. The first step when you're writing out a net ionic equation is to write the traditional non-ionic equation. There are no ions shown here. I balanced it. I included the states. My next step is to write the total ionic equation. Any chemical that's aqueous, I'm going to dissociate into its ions. This is going to be quite a long line, and that's okay. The strontium nitrate is aqueous. It's going to separate into its ions. Strontium ions. How many strontium ions are there? There's just one. But also, how many nitrates are here in this equation? There's two nitrates. So I'm going to have a strontium 2 plus ion and two nitrate ions. I need to be very careful with my notation. If something is charged, I must show the charge. Because the original compound was aqueous, the ions that are the product of its dissociation are likewise aqueous. I have Na2CO3, it's aqueous, separating into its ions. How many sodiums are there? How many carbonates are there? Two sodium ions and a carbonate ion, which is 2 minus, all of that aqueous. That takes care of the reactants. Moving on to the products. I have 2 NaNO3 aqueous. It's aqueous, it's separating into its ions. It's 2 NaNO3. How many sodiums are represented here? 2. How many nitrates are represented there? Also 2. Finally, I have strontium carbonate solid. This precipitate formed is a solid. Solids do not dissociate. So I'm not going to separate this into its ions. I'm just going to recopy this solid into the next line. This middle line is what we call the total ionic equation. It can get quite long. I'm going to look very closely now. Is there anything that's identical on opposite sides so that I can cancel? 2NO3 minus aqueous, 2NO3 minus aqueous. That's the exact same. These nitrates cancel off. They are spectator ions. Is there anything else? Oh yeah. 2Na plus aqueous, 2Na plus aqueous. That's identical. I've completed all of the canceling. All of the spectator ions are going to be crossed out, and I'm going to recopy what's left behind. I have strontium ions and carbonate ions reacting together to produce solid strontium carbonate. I can review the whole process, or my quick double check is this net ionic equation will be balanced in two different ways. The chemicals themselves are balanced, one strontium on either side, one carbonate on either side. In addition, the left and right hand sides of the reaction will have a charge equality. 2 plus and 2 minus on the reactant side means the total charge of the reactants is 0. They cancel off. And my compound on the product side does not have a charge. The chemicals work out to be balanced, and we have charge equality on opposite sides of this reaction. And I hope that helps.